In this video, I'm going to show you how to factor trinomials with a leading coefficient not equal to 1. So our leading coefficients here are 6, 4, and 6. And the method I'm going to use for factoring is called the slide and divide method. So here's our first problem. Let's factor 6x squared plus 7x plus 2. Okay, so we first want to test and see if this is factorable. So you're going to plug this into b squared minus 4ac. Our b is 7, so that's 7 squared minus 4 times a is 6, c is 2. So we get 7 squared, that is 49, minus 4 times 6 times 2, that is 48. We subtract these, we get 1. So 1 is a perfect square, so this trinomial is factorable. Okay, so let's start by multiplying the 6 and the 2 together. 6 times 2 is 12. And then we're going to set this 6 off to the side. We're going to come back to that later. We're going to drop the 6 in front of the x squared because we multiplied that by the 2. So we got x squared plus 7x plus 12. We're going to put the 12 on the top, the 7 on the bottom. So we want to find factors of 12 that add to 7. Okay, as it turns out, 4 times 3 is 12, and 4 plus 3 is 7. Those are the same there. So we want to use 4 and 3 as our factors. Okay, so we got x plus 4 and x plus 3. Okay, now that 6 that we set aside is going to come into play, so we're going to divide each of these by 6. And what you want to do is reduce the fractions as much as you can. So for 6, you can divide the top by 2 and the bottom by 2, so that becomes 2/3. 3/6, you can divide the top and the bottom by 3, that becomes 1/2. Okay, so now we have the fractions reduced as much as we can. So now you're going to move the denominator up in front of the x on both of these. So this becomes 3x plus 2, and this one becomes 2x plus 1. Okay, so this is our next problem. Let's factor 4x squared plus 20x plus 3. Okay, so we want to test and see if this is factorable. So we're going to plug this into b squared minus 4ac. b is 20, so you got 20 squared minus 4 times a is 4, c is 3. So we got 400 minus 48. That is 352. Okay, so as it turns out, 352 is not a perfect square. 18 squared is 324 and 19 squared is 361. 352 falls between those two, so it cannot be a perfect square. So this trinomial is not factorable. Another term for it is prime, so you can call it prime. So here's our third problem. Let's factor 6x squared plus 7x minus 20. Okay, so let's test and see if this is factorable and plug it into b squared minus 4ac. b is 7 squared, minus 4 times a is 6, c is negative 20. 7 squared is 49, minus 4 times 6 times negative 20. It's 49 plus 480, which is 529. 529 turns out to be a perfect square, so the trinomial is going to be factorable. Right, so first we're going to multiply 6 and negative 20 together. That gives you negative 120. We're going to move the 6 over to the side because we're going to come back to that. Drop the 6 in front of the x squared because we multiplied that by the negative 120. You're going to put negative 120 on the top, 7 on the bottom. Factors of negative 120 that add to 7. Okay, so as it turns out, 15 times negative 8 is what we need there, because 15 plus negative 8 is 7. So we need the 15 times negative 8. So 15 and negative 8, x plus 15, x minus 8. All right, now that 6 that we set aside, we're going to divide each of these by 6. And then you want to simplify those fractions. You can divide the top and the bottom by 3, so that becomes 5 halves. On this fraction, you can divide the top and bottom by 2, so that becomes 4 thirds. Now, after you've reduced the fractions as far as you can, you move the 2 in front of the x and the 3 in front of the x. So we're going to have 2x plus 5 and 3x minus 4.